What's up, CTM students? Welcome to the practice test for Chapter 2. You're going to see me go through each and every problem in the practice test. Looks like there are 20 problems in the practice test, so I will go over everyone step by step on here. And if that's not enough for you, you want some more practice, work through the problems in your Chapter 2 review on these pages just prior to the practice test there in your textbooks. And all of those answers are in the back, not just the odds, but all of them for those, so check your work as you go and make sure you're ready for that Chapter 2 test. All right, so you ready? Here we go. Let's go. Let's do this. So here's the test. Just copied the picture, or took a picture of the book. This is going to be a little fuzzy, it looks like here, but still legible, so I went with it. But hopefully we'll be able to read everything in here. I think it should be fine. Number 1, let's get rolling. Number 1, we've got this right here, 1 through 9. State whether each is true or false. If the statement is false, explain why. Okay, so is this equivalent to this? We have to know what equivalent means, first of all. So is it equivalent? And then it looks like number 2, we have this thought that it's equal instead. So the difference here, equals, has to have exactly the same elements, and equivalent means they have to have the same cardinal number. They have to have the same number of elements. So right here, number 1, this has 4 elements right here, from here to here. There's 4 elements in there. And I see from here to here, same thing, 4 elements in there. So are they equivalent? Yes, they are equivalent. They have the same number of elements. And it says if it's false, explain why. I'm going to explain why even if it's not false. I'm going to explain why if it's true. I'll just put that in parentheses. So same number of elements. That helps you out. That's what I'm here for, to help you out, all right? So I did a little extra there. So you just had to say yes, but same number of elements. This one's a no, because these are not equal because they don't have the same exact elements. I noticed that 3, 5, and 9, they all show up here. They're all here. They're just in a different order. That's okay, but this and this are not exactly the same. So this one is a no. They don't have exactly the same elements. So the elements are not all the same. The order can be switched, but they all got to be there. So H and J, not the same. Number 3, star, moon, sun. Is that a subset of star, moon, sun, and planet? And not just a subset, but a proper subset, in the sense kind of less than rather than less than or equal to. So is everything in here, and then does this have at least one more thing? So I see planet here. That's one more thing than what it has over here. Star, moon, and sun, all that's contained in this set. So I would look at that and I would say yes, that is going to be true. So explain. I'm saying yes and no. I should say true and false up there. I'm sorry. So true and false. Let's answer the question correctly, Mr. Wagner. There you go. True and false. This one's true. Why is that true? It is a proper subset because B/C for because all elements in the first set are also in the second. The second set, and there's at least one more in the second set. So both those things had to be true, and they both were true. Therefore, we say it is true. So this one, false, true. Up there, true, false, true so far. All right, number 4, 7. The set that contains 7. Is that a subset of the set that contains x, such that x is an element of the natural numbers, so 1, 2, 3, 4, 5, 6, 7, 8, 9, blah, 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 and x is less than 7. So let's think this one through a little bit. So another way to write this, is this true? Is this a subset? This time not a proper subset necessarily, just a subset less than or equal to in a sense. This I could rewrite as 1, 2, 3, 4, 5, and 6. So is everything in here? In here? No, 7's not in there because it has to be less than 7. If this was less than or equal to, then I would add a 7 in here, and then I could say it's true, but that is not less than or equal to. That's just strictly less than. And so is this true? I would say, is that true? With a question mark, something like that. I would say definitely not. So false. And why is it false? You got to say why it's false if it's false. So why is this false? You could be saying something like second subset. Let me just think of how I want to word this a little bit better. Just a second. My databases are out of date. Uh-oh. Okay. Bye-bye. And the second set is missing the 7. So I think that's the easier way to think about it. Your book, if I look at that a second, it says the second set has no subset that contains the element 7. So that's a fancy way of saying the same thing I said right there. Okay. Number 5, the empty set is that not a proper subset of 0. And so thinking about the empty set is always a subset of something else, a proper subset of something else, except the empty set itself. So the empty set, 0 is an element. It has an element in here. This has no elements at all. This has one element. Therefore, this is a proper subset of this. So we should get rid of that slash through there. It is a proper subset. So this one would be false. And you could say something like the empty set is a proper subset of everything except for the empty set itself. And if I look at the book, the answer there looks like that's just how they worded it too. So let's take a look at number 6. All right. P, Q, and R has 7 subsets. To figure out how many subsets something had, we were thinking that it's 2 to however many elements there are. It's 2 to that power. So 2 to the third is the number of subsets this has, that equals 8. Therefore, we can say this is false because there's 8 of them, and this says there's 7. So we can say false. There are 8, not 7. So we have that being the case there. What are those subsets? Just in case you were wondering, in case you're curious, don't forget about the empty subset. The empty set, sorry. And you could have all these different subsets. You can have the individual ones themselves. So this isn't something you have to write down, but this is just to show you what they would be. And you could have 2 in each one. So P and Q. You could have P and R. Or you can have Q and R. The order doesn't make a difference, but the elements in them do. And so that's 7 of them. What's the last subset? It doesn't say proper subsets. It says subset. So the set itself is also a subset. That was a horrible looking little face there. Let me get rid of that. Man, that's better. Little brace face, whatever you want to call that. That looks much better. All right, so I want to take this, and it looks like I'm going to run over to the next page. So let me get a new page up a second. All right, so we're ready to look at number 7 now. Number 7, it says if A intersect B, you got 2 sets where they intersect like that. A intersect B is the empty set, then A and B are disjoint sets. So disjoint sets have nothing in common. If you had something like this is a picture to help describe this. So you had A, you had B, you've got your universe, something like this. Everything's in the universe there. If they have nothing in common, that means their intersection would be the empty set. This is true. They have nothing in common. So this is an example of A and B being disjoint. All right, number 8's for any set A union not A equals the empty set. So let's think about that. If you had something like this one we've only got A to think of. So everything in A, I'll use some colors here, and everything in not A, oh, Merry Christmas there, hey, alright, red and green. Everything in not A, that's the whole universe. And so is that going to be the empty set? Well, I would say no, that's not going to be the empty set. This would be false. So there's something in that set. It's whatever's in A. It's the whole universe. So it's whatever's in A and not A. The whole set will be the whole universe. So I would say A union A prime actually equals U. It actually equals everything in your universe, your universal set there. Alright, so for any sets A intersect U equals A. So let's think about that in the context of that same picture. I'm not going to draw the picture again. So think about that again here. So A intersect U. U is actually this whole thing right here. So U, I could extend the green in there. So anything for number 8 that was either green or red or both was the union. And now we're saying, what's the intersection? Is it just A? Is it just what they have in common? Is it just this part right here? Yes, it is. It's the red and green stuff is that yellow stuff right there. So everything in the yellow circle would be that. And so this one, you would say it's true. If you were to give a reason for that, something like the intersection of A and universe is what they have in common. And what they have in common is A itself. So which is A. Alright, so that's number 9. Let's move on to a different set of problems here. Next exercises 10 and 11 use this set. A is the set X such that X is an element of the natural numbers and X is less than 9. So what is that set in roster form? Listing each one out, kind of thinking of a roster of a team. You're thinking of that in roster form. So what does that look like? I would say that A equals, and these are natural numbers, so this means the natural numbers, that's the set that contains 1, 2, 3, 4, 5, and so on. Like the positive whole numbers, in other words, the positive integers. You can think of it like that too. So, and though X has to be less than 9. So with this set, which one of these are going to be less than 9? 1 through 8. So if you're going to list them all off, which we should do here, if we're writing it in roster form, we're actually giving the roster. This is our team, you might say. Our team for set A includes the numbers 1 through 8, the natural numbers 1 through 8. And then number 11, what do we have here? We got a description of set A. So what is the description of set A? You can kind of come up with this in your own words. So I would say something like this. Maybe set A is all natural numbers from 1 to 8. You might also say set A is a set of all natural numbers. Wow, there's really natural numbers. Set A is all natural numbers from 1 to 8. So let me just do that. Set A is all natural numbers from 1 to 8. You could also say set A is the set of all integers from 0 to 9, something like that, or between 0 and 9, I meant to say. So if you're saying between, remember, it doesn't include those numbers itself. But you could say the book says it's a set of all natural numbers, or a set of all natural numbers less than 9. So that's another way to say the same thing. Alright, so you can put it in your own words as long as it is a correct way to put that. You're good to go. Alright, numbers 12 through 15 use the following information. So we're giving all this stuff. Right now I'm not going to draw a picture with this. We're just going to look at this and get what they are from the sets themselves. So what does A intersect B? In other words, what do A and B have in common? Over here I'll circle some things in red. So I'm looking for A intersect B. What do A and B have in common? Do they have 3 in common? Nope. Do they have 5 in common? Nope. Do they have 7 in common? Yes, they do. So they have 7 in common. Do they have 9 in common? Yes, they do. Anything else in common? No. So this one you would say that A intersect B is the set that contains 7 and 9. And that would be it. Number 13. What's this one? A union not C. So what's an A but not C? What is this going to equal? So let me erase my work over here in the red, and I'll think of this again in red, but starting over with my thoughts. So I've got A, I've got this one, the red there we go. So this one, and then it's not C, it's not C. So we're using not C, the complement of C. So what's in the universe but not in C? 3 is in the universe, but that is in C. 5 and 7 and 9, those are not in C. So 5, 7, and 9 would be all part of not C. 11 is part of C. 13 is not part of C, so that would be included in not C. 15 though is. So this is the whole set of not C. So we'd have to do that first. We'd think about that first, and then what would we have from there? So let me actually, I'll put that in red. I've already got it here. So I would write this actually with number 13 if you're working this out. Show me what not C is first, and then it's a lot easier to tell what's in A and not C, or A or I should say, sorry, A or not C. So either one, which one is in either one? So let's start with our whole universe and just kind of cross them off as we go. So is 3, is that in either A or not C? It's in A, so it is going to be in the union of those two things. 5, is that in one or both? It is in both of them in this case. So 5 gets included in there. 7, is that in either A or not C? Yes, it is. So that would be in there. How about 9? 9 is in both of them, so that's going to be in there. All right, how about 9? How about 11? 11, not in A, and also not in not C. So 11 does not get included. I'm just going to cross that one out. That is not included in here. 13, is that in A? Nope, but it is in not C, so I include it in A or not C. And then 15, is that in either one of them? Nope, no it's not. So 13 was, but 15 is not in either one, and so I'm going to erase that comma I just made because I'm done. That's the last one that goes in there. And so A union not C is the set that contains those 5 elements. All right, number 14. How about this one? So A intersect B intersect not C. So I think I'm changing my mind again. I'm going to put this up here. So not C was 5, 7, 9, 13. No reason to do that work again. All right, so let's start off with this one. Let's start off with what's in B and not C. B intersect not C. So what is in either, what's in both of those? So we're looking at B. Where does it intersect not C? Which elements are in both? So I see 7 and 7. That's in both. And 9 and 9. That's in both. Also 13 and 13 is in both. And so I would say, another way to write this, you could say A intersect, and then you've got the set B not C is the set that contains 7, 9, 13. So think of it that way. B not C is the same thing. This right here is the same thing as this right here. And so what's in A? So now let's consider A and this other set, this B not C. I don't think that shows up very well. Let me use a different color there. I'll go with blue. So let's look at this and B not C intersect not C. We decided we determined was these ones. So what's in, this is and again. So what's in both of those? 3 is not in both of those. 5 is not in both of those. 7 is, That's here and here. And 9 is also in both of those. So 9 and 7 get included in A intersect B intersect C. So this would be 7 and 9. And you maybe went through that whole thing and you were like, what the heck is he doing? Because that is not the question. So I gave you a bonus one. Woo! Bonus! Yay! Yay, Mr. Wagner, for making a mistake. Okay. Let's see. So this is not number 14. This is, I'm going to call it 13.5. Because you should still know how to do it. 13.5. Woo! Bonus! Bonus question. How exciting. 13.5. Woo! Woo! Yay! Confetti and everything else. Yay! Boom! A bonus question. Fireworks happening all over the place. Okay. Now, how about number 14? How about we actually do the right question? So this is B intersect C, and this is supposed to be the complement of that. So this is a completely different problem then. Let's write it like it's supposed to be written. Here we go. So let's try this again. Might there be a question like this one on the test? Sure, so we should know how to do that too. So you should just be excited right now that you got to do extra review at no additional cost. How amazing is that? So we'll have this is going to be the same thing as A and then intersect. So what's B intersect C? What do B and C have in common instead of B and not C? What do B and C have in common? Let's look here. B and C, that's these two, first of all. So what do they have in common? Not a 3, not a 5, not a 7, not a 9, but they do have 11 in common. And so this becomes, B intersect C becomes just the set that contains 11. So what's not in the intersection? So that means what's in the universe, in other words, what's here, but not here. So what's here, but not here? So we've got everything but 11. So you've got this whole set. You've got 3, 5, 7, 9, 11 is in there, but 13 and 15. All of those would be included in that set. Okay, so this becomes, you could say this is the set, in a sense, this is a set of 3, 5, 7, 9, 13, and 15. And so, excuse me, so what do A and this set, B intersect C, the complement of that, what do they have in common? So let's look at that up here. So now I'm looking at this set. I'll do this in blue. Looking at A, and then this one, B intersect C, the complement of that. What do they have in common? They've got 3, 5, 7, and 9. Those are in both of those. 13 and 15 only shows up in this one, but not in A. So what is the intersection of both those sets? You would say 3, 5, 7, and 9. And 13.5, amazing. That was all correct there, but just not the right problem. Done right, didn't start out right. Number 14 started out right, got the right thing now. All right, so let's check out. You could say the book even says this because it's true. A is the same thing as 3, 5, 7, and 9. Okay, and number 15 now. What is the number of elements, the cardinal number, the number of elements in this intersection? So I'm going to erase the stuff here and figure out what is that intersection. What is the intersection of A and not B? So first of all, I would have to know what's not B. So what is B? B is right here. B is this. So not B is going to be everything in the universe. So it's here, but not here. Here, and not here. So what is that? That's 3. That's 5. But it's not 7, it's not 9, it's not 11, it's not 13. Those are in B. And so it is also 15. And so A intersect not B. Now I would look at A and not B. What do they have in common? What do they have in common? So they have 3 and they have 5 in common right here and right here. And so how many elements is that? That is 2. So you have 2 elements in their intersection. So it's the number of elements in the set. Another way to write this would be to say something like this: number of elements in the set that contains 3 and 5, because this A intersect not B is the same as saying 3, 5. We just figured that out, and so that would be 2. There are 2, because there are 2 elements in the set A intersect not B. All right, moving on to number 16. So number 16, using the sets provided for exercises 12 through 15, draw a Venn diagram illustrating the relationship among the sets. So this is going to be a 3-set picture. We've got something like this. This is going to be my, I didn't need a square. I didn't want to make a square necessarily. But you know what? That's fine. I can use a square. I was going to use a rectangle. I'll use a square instead. Okay, that's my universe. And then I'm going to draw some circles in here. I'll give these circles some colors. Ooh, that'll be exciting. And we'll go with A with the red. We'll say B is the blue. And C is going to be in green. And then I'll just adjust these a little bit so I've got a little more space in their intersections. Grab the circle. There we go. And that looks pretty good right there. I'm just going to slide the blue one. Nope, the blue one. The blue one, thank you. A little bit closer there. And I'll make this square just a little smaller. That looks beautiful. All right. And so this is going to be my universe. This is going to be set A. This is going to be set B. And this is going to be set C down here. So what's in the universe? Everything here. But the first thing we want to fill in is this region. We want to know, do they have anything in common in every single set? And so I see 3 is in these 2 but not B. I see 5 is in this one but not anything else. 7's in 2 of them but not 3. 9. It looks like nothing should be in here. So nothing's in all 3 sets. Is there something that's in A and B? So let's look at that next. What's in A and B? So 3, no. 5, no. But 7, yes. And 9, yes. So in A and B, I should have a 7 and a 9. But not in this part, because that's also shared with C. This would be what they all have in common. Okay, so let's get rid of that then. How about things that A and C share? So A and C, we've got 3. And anything else? Nope, just that. So just a 3 is going to be hanging out in there, in the intersection of A and C, but not in B. How about B and C? What do they have in common? So B and C, what goes in this little space right here? B and C have 11 in common, but nothing else. So what goes in here? You'd have 11. Okay, so as we go, consider crossing these out. That's a good idea. So in your universe, go back to the universe. These ones are the ones that we've used. So what haven't we used at 5, 13, and 15? Is 5 in one of these? It is. It's right here. And it should not be in the other ones because we've already got the intersections all done. And so that verifies that, or that's a good thing that doesn't show up in C or B because they weren't supposed to be there. So we've done that right. So we're done with 5 now. And we just have 13 and 15. 13 is only in B, and 15 is only in C. So that would be right there. That would be right there. That uses everything in the universe, so that means there's nothing hanging out outside here that's not included in at least one of the circles. And so that is good to go. Number 16, I'll check my answers on that one. Looks like it's exactly what they got as well. So we are ready to move on. Number 17 then. Use a Venn diagram to determine whether these things work these things are equal. These two sets, this set and this set, would be equal sets for all sets A, B, and C. We're going to show our work to go along with this as well. So off to the side here, I'm going to draw another picture where I have, let's see, is that ready to go? I want this in black, not filled. Alright, we're good to go then. And I think I'm going to move this over here a little bit. Yeah, that'll be good. Alright, I'll make this a little bit smaller. And then make my three circles again. I've got A, B, and C. I've got three different sets. So it's going to be just like I had over here, something very similar looking to that. And so I'll draw a circle. And this should be good to go. Yep. So that's going to be A. I'll go with this being B once again. I'll move these circles around a little bit. And this one will be C once again. Almost grab it, get it, come on, get the green one. Okay, just a second. Okay, got it. And this is our universe, call that U. Red one we're going to go with A, blue one B, and the green one will be C. And so what were these regions again? Kind of read it as a book, read left to right and start in A here. So we're going to call that region 1 right here. We're going to call this region 2, this region 3, this will be 4, this will be 5, this will be 6, 7, and 8. So make sure you label it like that. We want to be consistent from person to person. So again, read it like we would read a book. Start from the top and work your way left to right and all the way down to that right there. And you don't have to include these little lines above it, but sometimes I do, sometimes I leave those out. But Roman numerals there, giving us the region numbers for that. And so from there, we need to make a little table to go along with this. So let's do that. I'll make this a little thicker. I'll use black for that. There we go. And horizontal. Okay, so over here, I'm going to have this first part. I'm going to have A intersect B union not C. And over here, I'll have A intersect B union A intersect not C. I think not at all clear whether that's going to be equivalent to that, or that's equal, I should say, rather, to that. So is it the same shaded region in the end? So let's see what A intersect B union not C is. Not C, let's start off with that. So some of you may be able to leave some of these things or think of them in your head. I don't think this is a good one to think of in your head, though. I would say look at C and then determine what not C is, what regions are contained in not C. So this, I would say, would be, it's going to be 1, 2, 3, and 8. 4 through 7 are in C, so 1, 2, 3, and 8 are not in C. From there, should be pretty easy to determine, I think, what B union not C is. You may want to write down B if you're not clear on that, but B I can just look here and say it's 1, 3, 5, and 6. So 1, 3, 5, and 6. What's in either one of those? Now, why don't I, since I'm fully explaining things, why don't I write down B as well? So what is B? B is 2, 3, 5, and 6. So 2, 3, 5, and 6. Okay? And so what is B union not C? What regions are in either one? They could be in both, but at least one of them. I see 1, region 1, region 2 is in both, so that's counted. 3 is in both, that's counted. 4, not in either one, so not counted there. Did I do that? Right, yeah, I got that good. Okay, 5, that's in B, so that's included. It's in at least one of them. 6 is also there, and looks like 8 is also included there. Let me expand this out a little bit, stretch this out a little bit more this way so I have enough room. All right, feeling better about that. So that's in B union not C. B union not C is all 6 of those. And so what is going to be in A intersect that? What's included in A? A would have 1, 2, 4, and 5. It would include those sets. So what's in both of those? If you look at this and this, what's in both? I see 1. Region 1 is in both. Region 2 is in both. Region 4 is not in both. Region 5, though, is in both. So what is your final answer here? A intersect B union not C would be those 3 regions. It would be 1, 2, and 5. If you were to fill it in up here, 1, 2, and 5 would all be filled in. So it's going to be this little sliver, this part, and this part right here. I'll fill it in yellow, actually. So it would include everything that I'm coloring here in yellow. It's going to include that. It's going to include that. But it's not going to include 4. So it's cut off right there. And you got everything there in the yellow. It's part of this whole thing right here. A intersect B union not C. So on this other side, what do we got on this other side? I've got A intersect B. I've already done the work over here for A and not C, so I'm not going to repeat that over here. I'm just going to go, and for B, I've got that here too. So A intersect B. What do A and B have in common? A and B, not 1, but they do have 2 in common. Do they have 3 in common? No, just here for 3. 4, no. 5, yes. 5 they have in common. And 6, no. 7 and 8, neither one of them have. Alright, so what is now A intersect not C? A intersect not C would be this part here and this part here. So what's in A and in not C? Is 1 in both of them? Yes. 1 is included in both. Is 2 in both of them? Yep. 2 is included in both. Is 3 in both? Nope, that's just in not C. How about 4? Is that in both? Nope. 5, is that in both? Nope. 6, nope. 7, nope, just in this one. 8, neither one. So that does it for that. So what about the last part here? So what's the final thing? A, I'm going to do my final parts here in red. There we go. A intersect B union A intersect not C. And so if you look at both, what's in either one? It can be in one or the other or both. So A intersect B has 2 and 5, and A intersect not C has 1 and 2. That would be 1, 2, and 5 included in either one or both. Now look at this and look at this. Are these things equal? Yes, they are. I don't even do that in blue to make that stand out even more. So this and this are exactly the same regions, and so we can say that are the sets equal? We can say yes, that they are equal. And it says show your work, we showed our work. So they're the same regions in the end. So if I were to fill in what's contained in this union, this, it would be the same stuff. It would be the same yellow region up there. So let's move on to number 18 now. And I'm going to move this over just a little bit more. There we go. So car accessories, Auto Accessories Unlimited surveyed 155 customers to determine information regarding car accessories their car had. The result of the surveys showed 76 had keyless entry, 90 had a sunroof, 107 had a compact disc player, 54 keyless entry and a compact disc player. As this video gets older and older, compact disc players, you might not even know what those are anymore. CD players, we now have all our auxiliary input and output stuff. Some of you may have never used a CD player in your life. I don't know. 57 had a sunroof and compact disc player. 52 had keyless entry and a sunroof. 35 had all 3 accessories. So first of all, we want to construct a Venn diagram. Try to make sense of all this first. So let's go back to our idea, and I will just draw a Venn diagram. I'll pause the video and put that in here. Okay, so here's my Venn diagram. Got it ready to go. This is going to be my universe. I'm going to go with red standing for keyless entry, and I'll call that, we'll go with K for keyless entry. I'm going to go with the blue being S for sunroof. I'll put KE for keyless entry, and then for the CD player I'll put that in green and I'll call that CD. So keyless entry, sunroof, CD. Start with the very middle. What do they all have in common? 35 had all three accessories. So we're going to start here and put 35 right in there. Alright, so now work your way out from there. Work your way to here, here, and here, the parts that just two of them have in common. So we took care of the 35. 52 had keyless entry and sunroof. So here's keyless entry and sunroof. 35 are included in everything. So what's going to go here is I'm going to work some stuff off to the side. Why don't I move this down a little bit so I have a little more room to work with up there. And over here I'll put that more like that. And so what value goes here? This is going to be your 52 minus 35 right there. So that's what's going in there. 52 minus 35 is 17. So that should be a 17 right there. That takes care of that. 57 had a sunroof and compact disc player. So that's going to be this little region right here, which is region 6. If you look back at the one we did here, region 6, what goes in region 6? That's going to be same idea, but 57 now minus 35. 57 minus 35, that should be 22. So 22 goes in right here. And what goes in right here? 54 had keyless entry and compact disc player. So 54 minus 35 is what should be in there. That's going to be 19. So we filled in all the intersecting parts. Now what do we have for just the keyless entry, just sunroof, just compact disc? And so let's go with CD player first. So what's going to go in for this value right here? I've already got 19, 35, and 22 all together in there. What's 19 plus 35 plus 22? If you take that value and subtract it, add them all together first, and then subtract it from 107. That will give you the value inside there. And then this right here, 19 plus 35 plus 22, looks like that would be 54 plus 22 would be 76. So 107 minus 76. Could use a calculator to figure these things out, sure, but I'm just working on my mental math here. So 107 minus 76, that should be 31, it looks like. And so we're doing the same sorts of things over here and here with the sunroof and the keyless entry. We should be taking 90 minus all those things, 19 plus 35 plus 22, which is the same thing as 76. So 90 minus 76, that should be 14 right there. And then this one, what value is that going to be? Oops. Don't go that far with it. There we go. Oh my goodness. Get rid of that. No, there. Alright. So this would be taking care of that. 76 minus 76 minus these three added together. So apparently there's none of them that have keyless entry without the other things added here. So 0 all goes in there. And then in the whole universe there's 155 customers surveyed. So what goes outside here is going to be 155 minus all these other values. So if I take, let me just get rid of that, I need a little more space here. If I take 155 minus all these other things added together, that's what's left over to hang out outside all the circles, but still in the universe, still in the number of customers that I surveyed. So I'd have 17 plus 14 plus 19 plus 35 plus 22 plus 31. So I'm not going to try to do that one in my head. Why don't I get a calculator out? for that and see what it gives me. So I'll add those things together first. My order of operations would tell me to do that first. And so I get 138, and then 155 minus 138 should be 17. All right, so 17 it is. So what should go here outside should be a 17. So all that work. Now let's just find this other stuff, hopefully very easily. So how many had exactly one of these accessories? Exactly one would be the stuff that's in the circles, but just in the red, not in any of these intersecting parts, just in the red, just in the blue, or just in the green. So I would say that would be it, and we add those things together and we should get our answer. And hold the phone a second there. Okay, so I meant to make this mistake because I wanted you to notice something. Alright, you wanted us to make that mistake. I don't think you meant to make that mistake, Mr. Wagner. Okay, whatever. You think what you want to think. So this is 76, but what did I do wrong there? I am sorry. I shouldn't have added 19 there. This should have been what's not in here. 17, 35, and 22. That's what I meant to do. Catching my mistakes so that I get it right on the test. Alright, so we have this. Now, instead of 19, that's not in the blue one. This is in the blue one. 17 instead. So this all adds together 74, making that part right here 16 and not what I wrote down. So that should be 16, not 14. And then over here, what happens here, I want to get rid of that and replace it with what's actually inside the red circle here. So 76 minus 17, 35, and 19. Minus 17, 35, and 19. Okay, so what's that going to be if we add all of those numbers together? These three added together, that would be 36, and 35 would end up being 71. So 71 subtracted from 76, that would be 5 left over. And so that changes things down here as well. So that's going to be 17, 14. I need to adjust a lot of these numbers here, so I'm just going to rewrite them again. So I have 5 included in here now. 5 plus 17 plus 16 plus 19 plus 35 plus 22 plus 31. If I add all those together, let's just verify what that is here a second. So 5 plus 17 plus 16 plus 19 plus 35 plus 22 plus 31. That should be 145. 145 subtracted from 155 is, so all this together is 145. Subtracted from 155 is 10. So that should be 10. My bad on that. 10 right there. And so what does this become now? 0, 14, 31. Have some different numbers here. So what's in there? You got 5, you got 16, and you've got 31. So that's this part right here, this part right here, this part right here. That's in just one of the three. Combining those together, it looks like that gives me 21 plus 31 would be 52 for part A. So now we're good to go there. Part B, which ones have none of these accessories? None would be what's outside of all three circles. That would be 10. So we just look at the diagram. That one's pretty easy to figure out from the diagram there. At least 2 of these accessories. At least 2 means it could also have 3. So that would include this whole area right here. Let me outline that in orange. I'm saying this whole thing right here. It could include anything in this sort of flower petal shape right here. So it's everything in here. Let's get rid of that. Alright, and so what's everything in there? It's going to be all 4 of those numbers added together. 17 plus 19 plus 35 plus 22. Add all that together. And let's see what we got. We got 36 here. 36 plus 35, that's 71. 71 plus 22, that's 93. 3. Okay, choice D. Keyless entry and a sunroof, but not a compact disc player. Again, in orange, let's decide what that is. So keyless entry or a sunroof, that would be in red or blue, but not compact disc, so not green. So it's just going to be this part right here. And what is that part right there? Right there is 17. So that one should be 17. And then part E, keyless entry or a sunroof, but not a compact disc player. So what's the difference between this one and the one we just did? This word right there is the only difference. Or a sunroof. So that means it could be in that, or both. So that means it could include this or this, but not compact disc still. So we're keeping the green circle out of this. And so we're saying everything in this region right here. That would be regions 1, 2, and 3 would be all that. So that was 5, 17, and 16. If you add those three numbers together, you are going to get 38. So 5 plus 17 plus 16, that would be 38. And then part F, only a compact disc player. What's only compact disc? That would be this part right here, the green part, but not including either the red or the blue circles, excuse me. That would be 31. So part F should be 31. All right, 18, pretty involved problem there. Lots of different parts to it, but that's how we work that out. And number 19, almost there. Show that the following set is infinite by setting up a one-to-one correspondence between the set and a proper subset of itself. So the set itself is this 7, 8, 9, 10, and this continues. We need to say what this is in general. It looks like we're starting with n, but if n is 1, that's where we would start with n. We would have to get to this first value of 7 by adding 6 to it. So n plus 6 would be the term. If you plugged in 1 for n, that would give you your first term, 7. If you plugged in 2 for n, that would give you your second term, 8. 3 would give you the third term, 9, and so on. The n plus 6 term would give you the nth term of the set. And so this, a proper subset. So to be proper, it has to leave out at least one of these values, and we usually just leave out that first value. So I would say 8, 9, 10, 11, and so on, up to this one would be n plus 7, because you'd have to start, to get 8 to start, you'd have to plug it in a 1 plus 7 would get you 8 to start. And then 2 plus 7 would get you the 9, and so on. And so what's the one-to-one correspondence? We got to show those arrows matching up, something like that, something to that effect. And so that is all we got there. So that's my final answer. It's the whole thing. Something like this is the final answer. So that was number 19. And then finally number 20. Following set has cardinal number, and then this is a little fuzzy there, but that's the Aleph null. So Aleph null, by setting up a one-to-one correspondence between the set of counting numbers and the set right here. So counting numbers, hopefully we remember those from before. That was the set starting at 1, 1, 2, 3, 4, and so on, going on up to n and continuing to infinity. And then this set, I'll say the given set, we're saying is here 1, 3, 5, and 7. What's the pattern here? It looks like we're starting at n. It looks like we're taking, I should erase that, we're starting at 1, but we're adding 2 each time. And so if you're adding a certain multiple, we're adding multiples of 2 each time, or we're adding 2 to the number each time, it would be 2n, because doing that, if you had 2 times 1, you'd add 1, you add 2. If you had 2 times 2, you'd add 4, and so on. But how do I start then at 1 if I have 2n? 2n would give me, 2 times 1 would give me 2, so I'd have to start with 2n minus 1 to give me 1. let's just verify that that works for the next one. So 2 times 2, that's 4. 4 minus 1, that is 3. 2 times 3, the third element should be 5. 2 times 3 is 6. 6 minus 1 is 5, and so on. So that works. That matches up. These patterns, the little trickier part is figuring out the pattern, but see what it's going up by each time. If you have something plus 3 each time, this would be 3n. If you had plus 4 each time, this would be 4n. If you had plus 20 each time, this would be 20n. And then just see what you have to add or subtract in addition to that to get that first value. Whatever that first value is, has to match up like that. Okay? And so that'll do it for us. That's the Chapter 2 review. Go back and review, pause, reflect on, rewind, go back, and just use this as a great resource for you in studying for Chapter 2, getting ready for Chapter 2 stuff. All right, hope you have a good rest of your day.